Compounds. Anytime two atoms join together, they make a molecule. Everything around us is made up of molecules. When atoms from two or more different elements bind together, the molecule is a compound. The chemical bond is so strong that the atoms from the different elements all behave like a single substance. Compounds are not simply mixtures or blends, but a bind that happens at the atomic level. Sometimes an element will lose traits when it is bound in a compound, an element that is creative on its own, meaning it will release energy in a chemical reaction with another element. Like sodium, Na, can become non-creative when it binds with another element like chlorine, Cl, forming sodium chloride, NaCl, which is everyday table salt. All compounds have a defined composition or definite composition. For example, a compound you may heard before is H2O or water. Water always has two hydrogen atoms and one oxygen atom. If you take away one of the hydrogen atoms, it is no longer water. While we have only 118 elements in the periodic table, there are millions and millions of compound combinations that are each unique. Alloys versus compounds. Alloys are not compounds. An alloy is a mixture of metals, or a metal and another element. Brass is an alloy of copper and zinc, which are both metals. Steel is an alloy of iron, a metal, carbon, a non-metal, and sometimes other elements. The alloy components are usually melted at very high temperatures, mixed, and allowed to cool to a solid alloy. In general, alloys are stronger and more durable than their individual components. Unlike compounds, alloys do not have chemical bonds between the elements. Common compounds. Some compounds you might know by the common names: baking soda, NaHCO3, milk of magnesia, MHOOH2, liquid bleach, NaClO, sugar, C12H22O11, marble, CaCO3, rubbing alcohol, CH3 2CHOH, table salt, NaCl. States of matter. All elements can exist in three different states of matter: solid, liquid, or gas. We use room temperature, a comfortable temperature of about 70 degrees Fahrenheit or 21st degree Celsius, as our consistent point of reference. At room temperature, the majority of the elements are solid, 11 are gas, and 2 are liquid. Elements change from one state to another through heating and cooling. When an element changes from one state to another, the number of atoms remain the same, but they arrange themselves in different ways. Solid. When an element is in solid form, atoms are attracted to each other and locked in a tight position. Solids keep their shape and have a fixed volume. Volume is how much space an object takes up. While some solids are soft and flexible, they're still solid. Liquid. When an element is in liquid form, the atoms move around and their attraction loosens. Liquids take the shape of the container they are in, but the volume remains fixed. Gas. When an element is in gas form, the atoms are weakly attracted to each other and move in different directions. A gas will fill any container, no matter how large or small it is. Alchemy and ancient chemistry. Long before the periodic table was developed, humans attempted to understand the unique and distinct substances that comprise everything in the known universe. What are the essential elements? Many ancient cultures, like the Babylonians, Chinese, and Egyptians, developed an idea of simple groups: wood, fire, earth, metal, water, and so on. The ancient Greeks synthesized the world into just 4 elements: earth, water, fire, and air. This theory became elemental to Western thought for 2,000 years. The four elements were used to describe not only objects in a seen world, but also the temperatures a person might experience and physical sensations in the body, called the four humors. Maintaining the balance of the four elements and humors was thought to be essential not just to the natural world, but also to a person's mental and physical well-being. Alchemists and gold diggers. In the Middle Ages, practitioners of alchemy, a combination of scientific exploration and mysticism, sought to understand the natural world and how to transform it. Alchemists were interested in purifying and perfecting metals and sought to change ordinary metals like lead or mercury into gold. The material that was thought to accomplish the task was known as the philosopher's stone. Of course, no such substance existed, but one alchemist, Hildebrand, became the first person to chemically discover an element in his pursuit. Read about the gross idea that led to his discovery of phosphorus on page 43. A scientific revolution. Building on the efforts and discoveries of the alchemists and riding the wave of new scientific methods, pioneering chemists in the 16th century began to dismantle the idea of the four elements. They discovered that what had been known as elemental earth, for example, was made up of many components. Much of their research involved how different substances that the alchemists had isolated, such as arsenic or zinc, interacted with each other or other substances, such as gases in the air. Because some substances behaved similarly under certain circumstances, scientists began to classify them into groups in the 18th century, which was the beginning of the periodic table and our modern understanding of the elements. Meet Dmitry Mendeleev, organizer of the elements and the author of the periodic table. On February 8, 1834, in a village of Siberia, Russia, a baby boy named Dmitry Mendeleev was born. That boy would one day change the course of science forever. He came from an unusually large family. No one knows for sure, but he likely had 14 brothers and sisters. When he was 13 years old, his father died, and 2 years later, the family's business burned down. In search of a better life, his mother took him from Siberia to St. Petersburg, where he gained acceptance to college. Despite poor health, Mendeleev graduated at the top of his class, and after a short stint as a science teacher, he returned to St. Petersburg to continue his education, focusing on chemistry.